Welcome to the Intelight tutorial 104 on max time startup logic. In max time, the very first parameter is the startup logic, so we can go to controller, go to unit, and we can go to startup flash. And the tooltip will tell you this value is in seconds from 0 to 255. Now this is the amount of control flash. It's the flasher controlling the outputs. When you power up the controller, it comes up. It's in cabinet flash until the controller becomes alive. It goes through a diagnostic period, usually about 8 seconds. So you got 8 seconds of cabinet flash, and then this interval comes in. Now, if you have a 0 in this parameter, it just gets skipped and goes to the next interval. However, you can put time in here. Now, it's important to know about the cabinet. In a NEMA cabinet, this controller program flash is being accomplished by holding down the CVM flash. So the monitor keeps it in the cabinet transfer relay flasher logic of red, yellow. In other cabinets, it's doing a program flash. So you have to program the colors you want to flash. So be careful about what type of flash, what type of cabinet, and how long it is. You don't want this to be longer than the monitor interval. This is a chart of the different intervals when you power on the controller. So you power it on, it comes up, it runs diagnostic while the cabinet's in flash. So you flash it through flash transfer relays. The controller comes on, and this is the controller flash that we just programmed. The next interval is the all red hold, so you can have a flash, an all red, or either or by having zeros in there. The second interval is this uh, startup clearance hold time, and you can put a value in there. This is your all red time. So if I wanted to skip this value, I could leave it at 0. So I could power up the controller, have 8 seconds of cabinet flash, 5 seconds of controller flash, and then immediately go to my startup phases. Or if I wanted to come up and run 5 seconds of hold, I could zero out the flash and put 5 seconds down here. So it would come up, power it on, it would be in cabinet flash for the 8 seconds, go directly to all red hold for 5 seconds, and then my startup phases. Or I could do both. I could put 5 seconds in both spots, so I could have my cabinet flash, my controller flash, and my all red hold. So I can do either or both, or none. I could set zeros in both of these if I so desired. Came directly from cabinet flash to colors if I so desired. The next interval that we're going to talk about after the all red hold is the startup timing phases. So in this case, we will go to phase configuration, and then we'll go to phase configuration, and we will define startup phases. So in this case, it's phases 2 and 6, green, no walk. So we will be running min green on 2 and 6 on startup. Now we could drop this down and we could pick yellow or all red or phase not on. Phase not on means the phase is red. It's not timing. But we're going to have to start in colors, so we were going to start in phase 6, 2 and 6, no walk. Now right now it's going to run the min green. So if we go and we looked at the min green value for 2 and 6, it may be short, and we may want to run a longer time value. So we'll go and look at that. So we have 5 seconds of min green in 2 and 6. So the controller would power up, 8 seconds of diagnostics, 5 seconds of flash, 5 seconds of all red, and then min green. Well, if we wanted 10 seconds of green on 2 and 6, we'd simply type 10 seconds in here and hit apply. Now, of course, we could zero out the flash or zero out all the red, or we could set this value to anything higher than the min green. So it takes the higher value of this and the program min green. You cannot go less. And once that is done, it would go to yellow on 2 and 6, all red on 2 and 6, and start timing the other. Going back to our chart, we can see that the cabinet flash is dictated by how fast the controller comes up. It's about 8 seconds. The controller flash, we have a value that we can program in. We just have to be careful we don't exceed the monitor release time, the all red value, and the startup phases. We can do a more exotic startup if we so desired, so that we could start up in two conditional phases. We could have primary phases and secondary phases. Right now, you can say 2 and 6 are our primary phase, but typically we will start up in yellow to make them primary. So we will go down here for 2 and 6 and make them yellow. And then we can skip to another set of phases and do some timing on this. So we could go to 4 and 8 and make them secondary startup phases. So we're going to time 2 and 6 yellow for a particular amount of time, which could be the 10 seconds here or another value. Go to the all red period and then jump 3 and 7 and go to 4 and 8. So it gives us a little bit more control time. Now over under the unit data, we put in some additional time values. So the minimum startup time is just on the primary phases. It wouldn't drive the 4 and 8 green. So what we did is we come over to unit data and we can put in a primary start value. So if we wanted 8 seconds of yellow, we can put 8 seconds in here. But we have 10 seconds of startup over under the phase. So it's going to look for the biggest value, either the 3 or 4 seconds of the phase time, which is the minimum amount, the min green startup, or the primary startup. So if we wanted 8 here, we could put 8 in, hit apply, but we would have to go back to phase configuration and either reduce it below 8 or just zero it out. So if you're in this application, it's probably just zero it out and use it all in unit data. We'll hit apply there, so that will give us 8 seconds of yellow. It goes to the all red interval, whatever the phase all red is, and then jumps to the secondary phase. Now the secondary start time is the amount of green on 4 and 8. So it's like before, is we want to have a bigger than just being green, so we can put 10 seconds of green in there, and then when 4 and 8 finish those 10 seconds, it goes to yellow, goes to red, goes around to 1 and 5 and continues the cycle. So this can be a little bit more exotic for a big intersection where you want to have a little safer startup condition, or you can do it the simplistic way and just pick a color phase with them. The last item I want to caution you on is that startup phases have to exist in all sequence that you're using. If you have a startup sequence and you're missing a startup phase, it's not logical. So, for instance, here we've got 2 and 6 as a primary, 4 and 8 are secondary. They have to exist in all the sequences that we're using. So, the first sequence is an 8-phase quad, but if we go to sequence 2, and maybe we want to omit phase 4 by time of day. So, we can do that. It's a legal sequence. We call for it by pattern, by time of day, but it will not start properly because phase 4 is a secondary start phase. And if it's not there, it can't start and it will never come out of flash. So this is a good tool tip. Always make sure that your primary and secondary start phases are available. It's a little easier when you just use them primaries. You have 2. Just be sure that they're always there and you won't have a problem with your startup. Thank you for watching this Intelight tutorial with me, and stay tuned for the next Intelight tutorial on unit data programming. Hope you see you then. Bye.